Hi, everyone. As I said, my name is Kenneth. I am Danish. We're supposed to be the most happy people in the world, but I think about a week ago, we're the second most happy people in the world. But as you see, even our sockets are happy. I work for a small company or medium-sized company called Intel. You might have heard about them. We work on chips and other things like the web. And my job is basically to look at this web platform and bring it forward, make sure that it covers all the needs of developers and businesses. So I work on Chrome and I work on standards. But we're here today to talk about smart devices. So one thing you could ask yourself is like, what makes a device smart? Like, is a device like this really smart if I have to pull out my phone, unlock my phone, let me find that app, let's launch that app, oh, there it is, there's my light, I can turn off the light. No, that's not really smart. Because like, we really want to solve real issues. And we want to be there when you need it, like a small button on your wall, like turn off the light. That's kind of useful. So you want like ease of use and low friction. I don't want to download an app, sorry. I just want to do stuff. And I want to do it now, like right now. And if you think about the future where people are talking about like Internet of Things, smart devices, you're going to not have one device in your home. You're going to have a lot of them. You want to maybe talk to your refrigerator, turn on the light, turn on the music. And this doesn't scale. If you have like 100 different apps on your phone, it's going to take a long time finding that app that you need at that point. It's going to look like this. Everyone remembers Windows, right? And now it's not switching to the next slide for some reason. Yeah, it broke it. It's the same thing even on Android today. It's like too many icons. You lack the overview. And then you get these like tedious updates like for apps that you never use, like, yeah, let me download. There's an update. You might need me at some point in the future. Yeah. So, but let's try to look at some of these use cases for these smart devices and apps. Like the smart device you'll use like every day, like turn on the light, turn off the light, something that you probably do every day. There's some you use like once in a while, like, hey, let's check how the temperature is outside, let's check the humidity of my plants or whatnot. And there's some apps that you use maybe once, like maybe I'm traveling to Sofia, I rented a car, I need to park somewhere, and I need to pay for parking. So like, do I really need to download an app for that? On roaming? Really, I just want to pay. So maybe there's a better model. We want this low friction and we want like ease of use. Like everyone gets this experience, like a URL, the web, like just type in the URL and there you are. Low friction. If you don't visit the site again, it's like ephemeral, it will disappear. Because they have like a cache, it's in the cache and when you don't use it, it'll just get replaced. But for the web to really work for these use cases, it needs to be fast. So like the last couple of years, we really worked on making the web better on mobile. And I would say it's so much better today. It's amazingly good. We've been focused on speed. There's like the new HTTP2 push, where you can actually push resources to get what you request. There's something called Service Worker, which there's a guy talking about later today. And there's something called the Pebble pattern. So first of all, like a short intro to Service Worker. You're used to having like your web browser. If there's no internet connectivity, you normally get the dinosaur, at least if you're using Chrome or something similar. But with Service Worker, you can have like this proxy server in the middle. So when you're online, you can actually cache things. And then like when you're online, you just, like when you're offline, you just show what's in your cache. Or you can like program it and do all kinds of fancy things. So I'm sad to say the dinosaur is going to go extinct. There's also a new pattern to make like things really, really fast. So one of the things with the web that you don't have so much with like these native apps, because with a native app, you download it all. You force users to download the whole app in the beginning, whether they'll just use like 1% of it. So with the web, the idea is that you just like find out like what you need right now, like for your view, and you just download those critical resources. Then maybe in the background, because you know, oh, well, if the user is going to log in, he'll probably need this as well. Then you can download things in the background, you can prepare it, you can even have it in your Service Worker, and then you'll just like lazy load it and show it. So purple pattern is a new pattern from they tried to develop at Google to find out a good way to do this on the web. So the base takeaway is that web is actually pretty good for these use cases today. It can work offline, it can be fast and responsive. So let's take a look at like an app. I'm clicking on the icon on, there we go. That's a web app. It's pretty fast. I don't know if you can play it again. Okay, let's see. Nah, let's just continue. But people say like, well, this is not the web. I didn't see any address bar there. It launched pretty fast, and there was an icon on the home screen. Well, this is an experience we call progressive web apps, and the talk after this one is going to go into that. It's going to explain all about progressive web apps and what that is. So the thing here is that the web is really good for like these one-time use cases, like paying for your car parking, because you have this low friction. Type in URL, and there you are. It can also be really handy, like if you really wanted like an icon to turn off the light, you can have that on your home screen. And you don't have the clutter of the address bar. You can avoid that and make it look like a real native app using this called the progressive web app thing. And the cool thing about the web is that it's safe from the beginning. It's supposed to be safe because you just browse the web. You just type in a URL. You don't want to type in a URL and suddenly something happens. It's bad. This is kind of different from when you install like a native app because they have like a lot of powers from the beginning. So they'll just ask you maybe up front, they're trying to do that less, like, hey, I need to access all your contacts. And people are like, I don't know what that means, but I want the app. Okay. But on the web, we've worked really hard to make everything really safe. But it's living in a sandbox, and all these devices you want to talk to, they live outside of this sandbox. So how do we get there? Can we do that on the web? Yes, we can. So just one thing to keep in mind when thinking about like developing like smart devices is that companies or users, they don't care about technologies. They just want things to work. So I'm going to look at two very common technologies today. One of them is called Bluetooth. You probably know about that. I don't know if you know the other icons. That's the USB logo. So what are the advantages of Bluetooth? Well, Bluetooth is widely used. Since Bluetooth 4, there's something called Bluetooth Low Energy. It's like the replacement of classic Bluetooth. So it uses very little power. And like the main advantage is that it's wireless. You don't need any wires. It's also pretty cheap, easy to use, and it has a built-in beacon functionality. It means that the device can kind of like say, hey, here I am. Some of the disadvantages could be like security. It's a wireless protocol, so you're actually sending things in the air. So well, people might be able to see what you're sending, or like interrupt it. It could also be a problem, for instance, in a hospital where you have machinery that might be affected by these things. As it's not powered, you will need like an external power source for the device, which could be like maybe it's plugged into the wall, or maybe it needs a battery. And of course, like the speed and the stability as well. Let's take a look at like how this could work today with something called Web Bluetooth. Just selecting the device, just connect it to a candle, pops up a web app, and from the web app you can actually change things. See? So that's like the low friction part of it. And this is the specification for Web Bluetooth. It's a new thing. It's based on Bluetooth 4, so like the future of Bluetooth. They just announced Bluetooth 5. It's based on the same thing. This is what people usually call low energy, or sometimes they call it Bluetooth Smart. The API, the application programming interface, is really modern, really easy to use. I'll show examples of that for people who know how to code in JavaScript. It's using something called promises and typed arrays. But it only connects to peripherals. You cannot make your web page act as a device itself. You'll connect to other devices. And it doesn't support the classic mode. So support is getting pretty good. It's supported on Chrome, on Android, also on Mac and Linux, and on Windows they're working on it. With Web Bluetooth, you need to have a secure connection. So it requires HTTPS. This is basically the new standard for the web. Every new feature requires HTTPS. If you don't have that, well, There's a lot of things you're missing out on. And for security reasons, you don't want to just go to a web page and suddenly connect to your microwave. So it kind of like it forces you to do a gesture. You need to click on something, like a connect button, which will then show up like a dialogue, so you know what's going on. So this looks something like this. Like I go to my web page, I click on connect here. Now I'm connected to a polar belt, heart rate belt, and there you go. The user always knows what's going on. The API is really, really easy. If anyone knows knows JavaScript, you can see you just do like request device. You select the service you want to connect to. There's some standard services in Bluetooth 4, like battery service. Sometimes with devices, they make up their own thing, so they might have a UUID instead. And that's basically it. You can also advertise things using names, like I've done some of my own devices. So now I'm just filtering for my name, like Kenneth Robot. That works as well. The way the Bluetooth low energy works is that you have something called a profile, which has a service inside. And inside that service, you have characteristics. If you know JavaScript, you can think of this kind of like, the service is kind of like an object, and the characteristics are kind of like properties. Like it could be like a Boolean or a string or something like that. But as this is kind of like a binary protocol, people they tend to use like an array or like a byte array instead. So some of these properties often like includes more than one value. But it's kind of like an implementation detail. Now I'm trying to go a bit further. So I connect to I get my device back. When I get my device, I connect to this GATT protocol, the generic attributes protocol. Very easy. And from there, I can get the characteristics. So these are the values. So here I'm asking for the battery level. And then I can say, hey, read value. So I can actually like show what is the level of the battery. Very, very easy. I can also write things back. So send things to the device. So here I'm just creating like a byte array with 1, and I'm sending that. Just calling write value. Very, very easy. But many, many times you don't want to like ask for things or write things. You want to like, hey, tell me like, for instance, if it's a temperature sensor, you just want to get notified when something changed. Or like the heart rate you saw before. So you can subscribe to value changes as well. So that's what I'm doing here. I just add like start notifications, I add like an event listener, and there we go. Very easy. I talked briefly about like beacon functionality before. So this is built into Bluetooth, but it's kind of like a low-level API. So companies that know exactly how to look for beacons, they can build something on top of it. And Google, they looked at seeing like, how can we make this work for the web? So they defined a protocol on top, which they call Eddystone. And the big part of Eddystone is what they call the physical web. It's like a standard way that these devices can send out a URL. Basically a way to say like, hey, this is me, or hey, it could be like a beacon that's not doing anything else, so maybe you have it at the bus stop, and it'll just say, hey, this is the bus stop app, or the bus stop website, progressive web app. Or sometimes you can even like, hey, this is me, now connect to me. So that's pretty cool. So it will look like something like this. It's changed in Android today, but this is like one example what they did in England. So you go to the bus stop, it will just like show on your phone, here's the estimated time of arrival for the next bus. Super useful, you click, and you already get into the experience. And then you can do more, because now you're in the app. You only got that piece downloaded that you needed at that point, and from then on you can click elsewhere, like say, hey, what are the stations? It also works really well for examples like you want to pay for things. Maybe you walk up to the parking meter, it's like, hey, this is me, pay. And you pay, and there you go. But I'm not going to go into more details about this, so I'm just putting a URL here. At the end, I'm going to share my Twitter account, so you can like follow me on Twitter, and I'll share a link to the slides. So let's look at the USB. USB is also widely used. You probably have USB cables. It's very cheap. It's cabled. As you have like a real connection through a cable, it's more secure. It's also faster and more stable. And what I think is pretty cool is that you can power devices using it. You can say that the disadvantage is that it's cable. It kind of depends on your use case. But as I said before, there's no radio interference. And the cool thing about USB is you can imagine, like, I have a big factory, so I have like big machinery. I really want to control them using a web app. So I don't like people to be able to go into my factory and pull out the phone and connect using like Bluetooth and suddenly, oh, that's a security risk there. But with USB, you might have a hatch requiring a physical key. So you actually have to open up that hatch to put in your USB cable. So you can make it secure. And as I said in the beginning, users and companies don't care about technology. They just want the solution that works best for their use case. So both technologies work really well together. So I'm showing one example here. Okay, let's see if I can make it play. No. Can you press on the play button? So this is an example I did at home.
Hi, let's check out what you can do on the web today.
Voice.
Let's just plug in this device. Just a second. Plugging it in. Look at the computer, what's going to happen. It's currently just starting up. So there you go. Oh, there's a nice web USB device available. Just click on the link. Shows up in the browser. Now I already connected so you can see it already has the web USB permission. So I can just run this piece of code. It's a very simple demo. It's looking at the temperature sensor and showing the temperature on the LCD. I just pressed send and there we go. To just show this is actually live, let's just change one of the demos. Take RGB, run. This is going to change to, oh, there you go. Pretty awesome, right?
Now can you click somewhere else, because otherwise I cannot. Yeah, there we go. So this was like just one example showing like what is doable on the web today. So what you saw is that you had a device that was actually powered over USB. It had the bootstrapping, like it showed up a dialog, like, hey, this is me. Click here to go to my URL, because users might not know the URL. And then I actually showed like this device capable of running JavaScript. So I was actually coding the device in my browser directly. I think it's kind of amazing what you can do today with the web. USB, as I said, this is a much more powerful protocol. It's cable, it's really fast. So it has like 3 different ways of sending data. They have bulk transfers. It's like the standard things. It's what you use like for serial connection or printers. You just try to send as much data as possible, but there's no guaranteed timing. Sometimes you really need timing. So for instance, with a mouse and keyboard, you don't want to type and suddenly wait like 2 seconds before actually seeing it on the screen. So for something like that, you would use like an interrupt protocol instead, which ensures like a maximum latency, but it's slower. And sometimes you just want to broadcast things. You don't care if it arrives or not. Just like try the best you can. Send all the video through this cable as possible. For that, you have the isochronous transfers. Web USB adds a few things on top of USB. So USB devices, they have headers, kind of like saying like, this is the kind of device I am, these are the protocols, etc. But there's a few extra web USB headers you can set. These are not required, but they're required if you need something like the like the bootstrapping dialog, and it also allows you to restrict your device to one specific URL or a set of specific URLs. So for instance, I'll plug in my device and we'll show a nice dialog like this. There's a few issues currently with USB. USB is an old standard, especially on Linux. A lot of people, they like to use like serial connections because it works really well, it's easy to use. But on Linux, there's something called the modem manager, which always tries to hijack all the serial connections. And it will wait for 16 seconds before it gives up. As it has like claimed the device, you cannot connect to it. So I'm just putting this out there if anyone is working with web USB and runs into this issue. That's really annoying. You can fix it yourself on Linux. It might take a while before to actually get into distributions. But for something like Chrome OS, which is probably what most people would use if they're using a Linux machine, you can actually just submit a patch to Google, and they'll merge it really quickly. On Windows, there's also a lot of issues, especially on older version of Windows, because you kind of need to pay for a certificate. But with Windows 10, it works much better. You need to add a few additional, in some cases, you need to add a few additional Windows headers. So I'm just writing the details here. But let's look at an example how you'll connect to a USB device. So this looks very similar to what you saw with Web USB. It's slightly different. You see, like, I need to select configuration, claim interface, and have like control transfer out to send data. And later down, I have like transfer in to send data in. There are like different versions here for whether you're using asynchronous, bulk transfers, etc. But we're using the web the latest and greatest, so you can also do the same with something called async await. I'm using promises before, so it's slightly easier to read this kind of code. And the cool thing about Web USB is that it actually works today. It's right there in the browsers in Chrome. It's behind a flag, but this is probably going to ship soon. As before, here's a URL where you can learn more. Wow, that was a lot of info. So you saw the web is really good for these like one-time interactions. But there's a lot of companies, normally companies, they deal with things, they need to track things. Like if you have a small shop, you'll have products. And this is normally what people say that this is what I really need. So you want to like read things, you want to like have something like barcodes, QR codes. And you can do this on the web as well. In some cases, beacons is the best solution. Sometimes you want something like NFC where you actually have a physical connection, like you need to touch things. But sometimes barcodes work pretty well because they're very cheap and you can just print them. And there's coming an API in Chrome that allows you to interact with these as well. So this is like showing a barcode reader, how you can read a barcode from your web browser. This is actually part of something called the shape detection API. So this actually scales to like face detection and all kinds of other detections. You can put it on an image, or you can give it a stream. So you can like a live stream, or just like give it an image, like say, where are the people in these pictures? Or what barcode is this? With NFC, we have a similar API. This is also in Chrome, behind the flag. This allows you to easily like push like a message to an NFC tag or read from it. Here I'm showing one example. I'm watching for changes. Like so, if someone puts their phone close to a tag, it will call this code. So I don't know if you know how NFC works. It's kind of like you have like this passive and active devices. So your phone would be called an active device because it's powered. A tag is passive. It has no power. It's just circuitry. So when I place my phone close to this device, the phone will actually power this device. And at that point, it's going to read what's on it. So you can write and read at the same time. So what I'm doing is I'm watching for touches. If it's initially empty, I just put some data to it. I'm just using JSON, so it's really, really integrated with how it works on the web. I'm just writing my name. Or if not, I'll call this called process a message, which is going to look what's on the tag itself. So on the other side, you can see that when I go through all the messages, if it's JSON, I'll print out the name I just wrote. Or if it's like an opaque with an image, I'll actually show the image. So I'm just trying to show this is a very simple API that allows for really cool use cases. And I even got the inventor of the web really excited about this. If you know that guy, that's Sir Tim Berners-Lee, who actually invented the web. So sometimes you need to connect to different devices in order to control things or to get input, like a sensor. So a lot of people that ask me, so this is pretty cool. I could connect to a device, but my phone already has sensors in it. Why can't I get like the gyroscope or accelerometer for my phone? Because that's pretty useful, maybe for writing games or detecting like when I'm walking and things like that. So we've been working on that. So we tried to come up with a very nice API that allows you to connect to the sensors on your phone, but also to connect to remote sensors, like in your IoT devices or whatnot, with the same API, the same way of doing things. So we created like the generic Sense API, and then like different smaller API for the specific sensors like gyroscope, magnetometer, accelerometer, ambient light sensor, and much more. We're even working on orientation sensors now, like relative orientation sensors, absolute orientation sensors, and much more. Just to show you how easy this is. Look at this code. I'm creating an accelerometer, setting the frequency, and a gyroscope. I can subscribe to on-change event, and then I just start listening. Very, very easy. This is a bit more complex, so I'm showing, like, I'm trying to do I'm merging, this is actually called a complementary filter. So I'm merging the gyroscope data together with accelerometer data. I'm just doing a bit of math, but you see, like, it's very easy. I just access the values and do my math here. So I'll show you a small video of how to do these things. So I got the Google Daydream, this thing. It's pretty cool, but it had like this nice controller. I thought, hey, that has like an accelerometer and a gyroscope inside it. And I already made like a small demo app that just shows you how to use this on your phone. So I thought, like, hey, can we do that? And I exposed it as generic sensor. So this is my demo app. I just connect to it, and suddenly I can use that as a controller. So you can imagine in something like WebVR, where you might buy a small device, like maybe a sword, like a plastic sword, and this device inside it. And maybe just in this, like, maybe game, you just pick up a sword and suddenly it's in the game. And you can do all of these things using the web today. So I thought this is pretty cool, but I had also this device at home. This is called Arduino 101. It runs something called Zephyr. So this is another project I worked on. So I worked on enabling JavaScript development on Zephyr. So this was the demo I was showing before. And I just got like an even smaller version of it, like literally this size. Really, really small. So I tried to hook that up as well. Really, really easy. So there you go. Works really well as well. The cable is just for powering the device. It's not connected using USB. So I had this whole idea that, hey, cool, now we have this IDE. Like, shouldn't we make it like a real product? So we have actually been working at Intel on creating a real editor for Zephyr. So this is just in your browser. You plug in the device. If it has like Flash with the right software, it'll just show up like an editor. And I can program it. So this is actually the code I was just using. So as you see, I programmed JavaScript as well. Create 2 different sensors. I subscribe to the change event, and then I transfer data. I'm doing a bit of trick here because I get like value something like 0.0112, but like I'm sending an unsigned integer. So I need to multiply it, and I need to shift it once to make sure that it has the negative or the positive sign. So it's just an implementation detail. This is the code on the client itself, the web app. Over here, this is just for me exposing it as the generic sensors, very easy. Here I'm just connecting. And this is basically just the code for like when I receive the values. So I know like how I sent them on the other side, so I just like unpack that again and call onChange. That's all I did. So you see like the web is getting ready for these like really nice app-like experiences without all this like app installs, being very flexible and very cool. So you can effortlessly connect to all these devices using Bluetooth and USB. This works currently only in Chrome, but I expect other browsers to implement this as well. Other technologies such as NFC and barcode readers is coming too. It's a bit further out, but it will get there, and you can play around with it already today. Generic sensor APIs expose these sensors to the web, all kinds of different sensors, and it will try to expose the same to IoT devices as well. So maybe on the web you have a gyroscope and accelerometer, but maybe on your IoT device you might have a temperature sensor, or humidity sensor, or something like this. But the cool thing here is that they all work the same way, so if you learn to code for one, you can code for all of them. So basically, the web is ready, so let's go build the future. And this is my Twitter account. I'll be sharing the slides afterward, so take a picture or write it down. Okay, thank you.
Thank you, Kenneth.